Hola Alicante. And that's pretty much all the Spanish I know. So, yeah. So, I hope you people had a great fun yesterday and excited about today, right? Good for you because this is me right now. I'm damn nervous. So, in case in the middle of the slide you people feel that we don't know what the heck she is talking about, trust me, I share the same feeling. But I am excited because just before 10 days I met with an accident and still I flew 8,000 kilometers to be here. And in case you were wondering why I got the privilege to sit down and talk, you know why. So, okay, quick introduction. I'm Anisha. I'm a software developer from India and I work with Salesforce, one of the leading CRM in the industry. So, in case you need one, you know where to get it. It's a free promotion. Okay, so getting to the real part, today we're gonna talk about clean coding architecture in React. And what the heck is clean coding, first of all? So over the last few years, we have seen a whole range of ideas regarding architectural systems. Though these all vary in details, but they do have the same objective, which is separation of concerns. Each of these architectures produces systems that are independent of frameworks. We should be using the frameworks as a tool, frameworks or library as a tool and not really depend on the framework. The system should not change when we change the framework. The system should be independent of UI, so the UI can change easily without much interference with the original business rule. And then, of course, it should be independent of external agencies. So if somebody across the globe is changing their APIs, our system should not break, right? And then it should be independent of databases. So in case you feel like, no, I don't want to use SQL, I'll switch to MongoDB or Oracle, you should be able to do that without much changes. And then, of course, the most important part, the system should be testable without, in isolation, without maybe UI or web server or database. So, in fact, your business rule of the particular application should know nothing about the outside world. It should be completely isolated and should be testable without any external interference. So, this talk is heavily inspired by the clean architecture by R.R. Martin, aka the Uncle Bob. And in this three-layer coding architecture, in this three-layer architecture, we have first entities layer, which is the basic business object of the application. So it's very highly unlikely to change when anything else outside of the application changes or anything else in these other layers change. Then we have our application layer where we have business specific technical details. You can say that these are the use cases, and whenever anything changes in this layer, we expect it to depend on the domain layer, but not really change according to I don't expect domain layer to change according to this application layer. We're going to get into the details a little bit later in the slide. Just I'm going through the definition. And then we have our interface adapters, which are in infrastructure layer. So this is a layer where we will write adapters to communicate with external agencies like APIs or database or storages, and it will convert the response object from those external agencies into the compatible version that our domain layer or our application layer can consume. Now, all these three layers are connected with each other with a rule called dependency rule, where the outer layers can depend on the inner layers, but whatever changes we are doing in outer layers should not affect the inner layers. Like the domain or entities must be independent all time. The application layer can depend on the domain layer, but changes won't affect domain. And same goes with the external infrastructure layer. So basically, we want our application to be as loosely coupled as possible. And what loosely coupled means is every component should have a very little knowledge about what the other component is doing. And so that these components can be reusable and modular. So ideally, you would want your architecture to be loosely coupled and highly cohesive, so that when the application grows, then we should be able to maintain it perfectly. Now, moving on to specifically the front end area, the last architecture might look something like this, where obviously we have our entities or domains, and they're not going to change. This like basic entities of the business role. And then we have a repository interface where we will have services to connect with APIs, databases, and storages. Then the use cases similar to the previous image. And then we have our views, right? The base class for views in front end. And then the external interfaces to access the external agencies. We'll go through each layer one by one in next slides. So, but before that, why we need this, right? For small application, when we work, it's probably that we have been writing React application for a long time, and when the application grows, these layers keeps getting fatter, and they do so many things that it's very difficult to reason about that which layer is what. And there is a huge chance that when the application will scale, things might go south, and some things might not work as you expected. And even worse, that you might be trying to reinvent the whole wheel and still end up thinking that I'm stuck, right? And that's heavy stuff, like when your application is growing. So how clean architecture will help us? The basic divide and conquer. The best way to solve the big problems is to divide it into small problems and then solve it. And clean architecture does exactly the same. All these layers, they can be substituted with alternative implementation. So if anything changes in outside world, we can easily substitute it in different layers. And of course, when your application is gonna scale, it should also be compatible with the software evolution. And dependencies between these layers can also be controlled by decoupling them, because the data flow is unidirectional because of the dependency law. And then we'll be able to test it in isolation. Now, keep in mind that the most important fundamental thing in clean coding architecture is to recognize where the boundaries of these layers are, and to ensure that whenever we are communicating across the layers, we are doing it with well-defined interfaces. Now, a few considerations before I move on. Although this talk is specifically for React, and I'm going to show examples with React and TypeScript, but this concept can also be used with other UI frameworks, Angular, Vue, etc. And we are not going to talk about object-oriented programming today, so yippee! And we will also skip tests today, because that's not the main topic of the talk, but while walking through the examples, we'll also keep testability in mind. And finally, the examples are oversimplified, so do not use it in production. So the whole idea is to understand about how we can implement this particular architecture in the projects that we already have, and make it more modular, and hopefully once it scales, it will be easy to maintain. So I'm going to walk you through an example, which is thanks to Alex. Oh my God, I again forgot the surname. I'm so sorry. I don't know how to pronounce that either, but it's mentioned in credits. So he explained it really nicely in an article. We are going to try to make an e-commerce website where we will be having some items that we can add to a cart and check out, and probably get a notification about if the payment fails or succeeds. And yeah, so typical e-commerce website. Now, let's talk about each layer in this example, right? So previously we talked about domains that don't change if we change anything in any other layer, right? Or if the UI frameworks change or any external agencies change. So in this particular example, there are a couple of things that don't change, right? For example, in an e-commerce website, there are your users, there is a cart, there are orders, then there are different functions to update those entities, right? For example, you can change your username and stuff like that. So those functions are called domain transformation, right? So these transformations, for example, if I want to change my username, or if I want to add something to my cart, or if I want to see that what is the total price of my a particular order, then these things are independent of the outer world, right? Now, these transformations might be triggered by external events, but this they do not determine how they're gonna transform the domain itself. For example, if I'm adding something to a cart, we don't need to know that if the user clicked on add to cart or it automatically got triggered by a promo code, right? So these domain transformation are again isolated from whatever caused this particular transformations. Then comes the application layer, which describes the use cases. For example, in the add to cart, if I click on add to cart, then the application will go to server, it will send a request to a server and then perform a domain transformation and then redraw the UI and to get the response data. Also in the application layer, there are something interfaces to talk to outside the application, talk with external agencies that are outside the application, and those are called ports. We're going to talk about what exactly they are in later slides. And there are two types of ports. One are input ports, which are how our application connects with the outside world, and then output port says how our application is going to communicate with the outer world. If we are sending some notifications outside, or sending some data to another server or something like that. Then comes the outermost layer, where we write the adapters to interact with the external services. And adapters are... Wow. My watch likes to talk to me. Okay. So the adapters are needed to turn incompatible data from external services into a compatible format that our domain layer or application layer can consume. And adapters are a great way to lower the decoupling between our code, because if something changes in a third-party library, then we just need to change the adapter and the whole application doesn't know anything about it. And this low coupling reduces the need to change one module, right? And there are two types of adapters. Ideally, one is driving, which sends signals to our application, and then driven adapters, which receive the signal from our application. Now, we talked about why we should use clean architecture, but there are like two parts to the coin, right? We should also talk about why we shouldn't. So when we implement this architecture, the time is required not just for designing it, but also to implement it. So it might consume a little bit more time than we usually take. And if the project is really small, it might be over engineering as well. And it will be difficult even if it's easy to maintain in later stage, but if somebody comes to check the project initially, the onboarding might be a little difficult. And obviously, since we are modularizing it, the amount of code might also increase. So something to keep in mind all the time to avoid these things is to obey the dependency rule, so that the data flow will be unidirectional within the layers, and then not to use something that looks like inherited, because we want to keep things separated, like separation of concerns. That's our goal. We already talked about this, like advantages, right? Like separating the domains and independent use case. Don't be affected by whatever is outside, and then we can replace the third-party services very easily. Now let's get into the application itself. So the user will like choose any number of items and pay for them because nothing is free. And we're gonna do it with maybe like some third party payment services, and we'll put items in cart and then we'll check out, and after payment we're gonna get a notification and stuff like that. So this will be the overall project structure that we can have in this kind of architecture, where we will have a folder for different domains. Then comes the application layer where we will have different use cases. For example, like if we are adding something to cart, or we are authenticating a user, or we are just ordering products. And then of course we have our ports to interact with our APIs through the adapters. And then services, where we are gonna write our services to, for example, in this particular case, we're gonna have a notification system or payment system, and something to store our data in. So yeah, that's the overall structure that we might go for. But again, this is very simple example. It might get a little complicated when you have a big application. So in this example, right, we already talked, we in the uh, domain layer we will have product, order, cart, and happy user, and we'll have like their transformation functions to mutate those domain entities. Is it visible properly, the code? Great. Okay, so as we know, we had 4 modules in the domain, right? User, product, shopping cart, and order, right? So in the domain module itself, the user can have user ID, name, email, and in the product we can have like it's again unique ID, the name of the product, and the price. And obviously the or sorry, in the order we'll have the in the cart we'll have like list of different products. And then again, when we place an order, we will have the cart itself, and when the order got created, the status of the order, if it is confirmed or declined, we can have that, and then the total price of that particular order, right? Now all sorts of things will happen when to these data types that we have just designed. Like we'll be adding the items to the cart and clearing it and updating items and changing usernames, and we'll create separate functions for all this transformation. To take a basic example, we have like changing usernames or adding product or checking that if an item is in cart or not. And in the product domain transformation, we can check that what's the total price like for the product. And then in the order we can have like how to create an order, right? So if the thing to note here is, in this stage there are no external constraints yet. So this allows us to reflect data transformation as close to the subject domain as possible. Yeah, I already told this. Now comes the application layer, where we can have use cases. For example, the product purchase scenario. A use case will always has an actor, an action, and the result, right? For an example, in the product purchase, the user is the actor, and the user is purchasing the product, and the result is obviously the product got purchased or declined. Uh, so in this case, we'll retrieve items from shopping cart, or and then pay for the order, and then notify the user if the payment fails and clear the cart. So now what should happen to data after adding an item to cart or proceeding to checkout? Use cases involve interacting with outside world, and these interaction to outside worlds are called side effects. Now if you see, the placing the order is basically a pure function. It doesn't have interaction with outer world. But after we click on that place order, we interact with outside world, and those are called side effects. So it's an impure context for pure transformation. We first perform a side effect to get some data, and then we do pure transformation on the data, and then we do side effects again to store whatever we changed. So this is what the use case will look like. We'll create an order, then we'll have a payment service, and then notification service to notify the user, and storage to save the data. Now in the designing of application, we'll order products, and when we want to order products, we need to obviously send the user and the cart all together, right? And we also will have some ports. We'll write services for them, as I mentioned, a payment system, and notification and storage. And in storage, you can have we can divide the storage according to the domains or entities. For example, you can have different storage for user, different storage for um, cart, or different storage for orders as well. This way, it will be easier to ensure that the functionality of different third-party services are not mixed up. So the posts that we just talked about, they should be, first of all, convenient for our application. That means that it should external services, if it is not compatible, we have to write an adapter to make it compatible. And note that we are talking about the interface of the services, not that implementation. So what third-party libraries exactly to use, we can keep the decision to the later stage. And this again helped us with decoupling the application, right? If something changes, we can replace. Now, these are the service interfaces that this kind we write. For example, in the payment service interface, we can take the price, the total price to be paid. We can write the port, and then in the notification service, we can get a message, and let's communicate with external APIs and send notification. And in the storage interface, the storage can be anything like Redux, Mobex, or whatever works for you. I usually like to divide the storage interface according to entities, as I said, and separate interface for user data and separate for shopping cart, etc. So these are the ports that we wrote to communicate with the adapters. An adapter will communicate with external agencies. And then we need to also declare the stuff for the services we are going to use. And we can create a function called order product, which we're gonna use to order the product. And inside the first thing that we have to do is create a new order, right? And if you remember that we created the create order domain transformation previously in the domain layer, and then we can import our services and simply use them to check if the order got paid or not. If not paid, then we can use our notify service to notify the user, and then update the order again with the domain transformation. And at the end comes the adapter layer. We declare adapters to external services, and on the front end, adapters are usually the UI frameworks and the API server request modules, and local storage or any third-party libraries. Now, here we're gonna talk with our external APIs. So for example, in the payment service interface, we can have a fake API to process the payment and get like set timeout and get something in return to check. And we explicitly return some value to our use payment hook over here, which we're gonna use in UI later. And similarly, an adapter for notification services as well. Like I have used like window.alert or any notification service that you are using. And then again, to for the store, we can have our storage service, be it context, and we can create a context and pass it to provider, or can use something else as well, and we can access it by hooks. So if you have noticed, we wrote hooks for each feature so that they don't break ISP and the stores, and at least in terms of interfaces, they will be atomic. Now comes adapter, where we'll be binding the UI and the use case. So the first adapter is it connects the browser API with the application. In case of the order creation, if we click on checkout button and click handler, which will launch the use case. So we have uh, we have defined one hook over here, we use order products, and then we are using the hooks that we provided in our previously for the notification, payment, and storage. And then we're gonna simply order the product, and we're gonna use closure to make these hooks available to the inside the use order product hook. And in the UI, on the right side, we can simply order products using the use order product hook. And it's important to note that the use case functions that we are using here are still independent of the rest of the code, and this is the only place where we are actually talking to the external agencies. So if we see here, the user interacts with the UI layer, like through a button in this case, and we can change this UI if we want to. And the use case are handled in the application layer, which tells us exactly what external services are required. And all main logic and data is in the domain layer, and the infrastructure layer hides all the external services. Now, some of the improvements that we could do is, first of all, we took price as numerical data. We take it as an object, like where we can put our currencies and the amount. And then we can also think about cross component use. For example, if we are using total price of the product, and that is in a separate component altogether, because order domain uh, and the product domain are different. So we can also like use DTO to have that feature. And then we also need to think about the domain dependency, because the two domains might be dependent on each other as well. So in this simple example, our order included just a cart, because and the cart represented a list of objects. But this the cart might also have like other dependencies. So in such case, it's better to use an intermediate data transfer object. And again, if you see this, the place order functionality, it's difficult to test without test it in isolation without React. So we should be able to improve that as well, because it should be testable. The business logic should be testable without any framework, UI server, or anything. Now, something to keep in mind, that the real scenario could be much more complicated. So avoid using inheritance, even if it's called extension, and even if it looks like that the interface is really inherited. And always break up the use cases in smaller atomic use cases, and obviously follow the dependency rule as much as possible. Now, a couple of more things. Obviously, don't overthink about the structure, and avoid using multiple nested files, because they are difficult to handle. Like, to stick with a particular structure and whatever works for you. And naming convention is really important, because there are like different modules might end up with the same name as well, and it's really confusing. So yep, that's all I have to talk about today. And hope I haven't bored you much. And so thank you. And